All right, so our objective or our goal for this video or for this section, because there's going to be broken into two videos, is to be able to solve systems by adding or subtracting to eliminate a variable. The key word here is eliminate. All right, because the method that we're going to use, that we're going to learn today in section 6.3, is the last method of solving a system of equation, and it's called elimination. And it's exactly because we're trying to eliminate a variable. All right, this is going to be broken up into two different videos. The first video is going to just be simple. And then the video 2 is going to be where we're going to have to multiply both equations. All right, so it is going to be broken up into two different videos. The elimination method, you use properties such as adding or subtracting, as it's shown here, where if you have 5 plus 1 is equal to 6 and 3 plus 4 is equal to 7, we can then group these and say, well, 5 plus 1 plus 3 plus 4 is then equal to 6 plus 7. So we're using these properties of adding and subtracting equations in order to eliminate a variable in a system, which is why it's called elimination. All right, just like we said in the last video, there's more than one way to solve a system of equations. We've learned two, and this will be our third method. And we will discuss this in class. Some systems are written in ways that make eliminating a variable a good method to use. Some of them are written in a way that substitution will be a good method. And we'll talk about when you should use each one. All right, so in the last video, we talked about substitution, or the last section. And in substitution, our goal was to say that x was equal to some number, or some expression, not some number, but x is equal to something, and y is equal to something. That was our goal. So that way, once we had what x or y was equal to, we can then substitute it into the other equation. Well, our goal for elimination, and if you've learned this before, your old teacher might have learned adding down or subtracting down. I'm only going to teach adding down. I think that there's a lot more mistakes that are made if you subtract down, so we're only going to do adding. And when we're eliminating, our goal here is to get in our two equations to have either a positive 2x and a negative 2x, or say a 3y and a negative 3y. So what our goal is in our two equations, in our system, is to have an x or a y value that are the same number but opposite signs. So 2 and negative 2. 3 and negative 3. So our goal in elimination is we need one of our variables to have the same number but different signs. And if they do, then we will add down and we will combine the two equations into one using these properties here of 5 plus 1 is equal to 6, so 5 plus 1 and 6, and then we can add 3 plus 4 is equal to 7, so we can add 3 plus 4 and 6 and 7. All right, so we're using those properties to go ahead and solve. All right, so now let's go ahead and do a problem, and we're going to solve this using elimination. So first we're going to rewrite this out. 2x plus 5y is equal to 17, and 6x minus 5y is equal to negative 9. All right, now as we already talked about, our goal is to have an x value be the same number but positive or negative, so different signs, or the y value be the same number but different signs. And if they are, we can just add down. Well, if we look here, we have positive 5y and negative 5y, so it's already set up for us to easily use elimination. So what we need to do now is we will add these two equations and we will combine them. And when we add them, we add our like terms. So 2x plus 6x is equal to 8x. And then 5y plus negative 5y is 0y. So it eliminates our y value, hence the name elimination. And then 17 plus negative 9 is then equal to 8. So then we'll just solve. So now here, once again, we had two variables, x and y. We couldn't solve. Now we're only down to 1, and we can. So then we divide each side by 8. So x is then equal to 1. And now we can substitute x into either of these equations. It doesn't matter. Neither one of these are really set up for us to solve very easily. So I'm just going to go ahead and substitute it into the top equation. So then we'll have 2 times x, or 2 times 1, plus 5y is equal to 17. So 2 plus 5y is equal to 17. We will then subtract 2 from both sides. And we get 5y is equal to 15. And then we'll divide both sides by 5. and you get y is equal to 3. So the final answer is 1, 3. And if we plug it back into both of these equations, does 2 times 1 plus 5 times 3 equal 17? Well, 2 plus 15 is 17, so it works. And does 6 times 1 minus 5 times 3 equal negative 19? Well, 6 minus 15 does equal, negative 9, not negative 19, and it does equal. So this is our solution of x is equal to 1 and y is equal to 3. All right, so that was the first problem. Now we're going to do one more that's not set up as easily as this one. All right, so now they want us to use this, use elimination to solve for this system of equations. So it's negative 2x plus 15y is equal to negative 32. And then our next system is 7x minus 5y is equal to 17. All right, now, what's important is that when we write these systems out, that you write your x's and your y's on top of each other like we have here, and then your constant on the other side on top of each other. You don't want to have your x above your y, because then you might mistakenly cancel out a variable that's not the same one. All right, but remember, our goal is to have the x or the y value be the same number but opposite signs. So in this example, we don't have one that they're the same number but opposite signs like we do here, like where it was 5y, negative 5y. However, we have 15y and a negative 5y. So they're really close to being the same number but opposite signs. If we just multiply this negative 5 by 3, we would have 15y and negative 15y. So what we need to do in order to be able to do this is we need to multiply the entire equation by 3, so that we're not changing the equation's value, but we're just rewriting it. All right, so we had the top one, negative 2x plus 15y is equal to negative 32. 3 times 7x is 21x. 3 times negative 5y is minus 15y. And 3 times 17 is then equal to 51. All right, so now if we look here, we have 15y and negative 15y. So now it's set up for us to add down. And when we go ahead and add down, negative 2x plus 21x is 19x. The y's will eliminate each other. And then negative 32 plus 51 is 19. Now we're down to one variable, so we divide each side by 19, and we get x is equal to 1. Same thing, once we solve for one of our variables, we plug it into either one. Since this one's dealing with a smaller number of y, I'm just going to plug it into that one. So I'm going to substitute, we're substituting in for x, so I'll substitute it into x because we have a smaller y for that one. So it'll be 7 times x minus 5y is equal to 17. So then we substitute 1 in for x, so 7 times 1 minus 5y is equal to 17. 7 minus 5y is equal to 17. Subtract 7. Negative 5y is equal to 10. That's 10. Divide each side by negative 5. And we get y is equal to negative 2. So our final answer for this one is 1, negative 2. And then to check our work, we will plug it back into the equations and make sure that it holds true. All right, that is it for this video. We have one more video, then we're done for this section.